this is a very quickly put together set of slides, but I think it's sort of a useful thing to get started and to structure the discussions a little bit. Some of it is also informed by, my attempt to write a phase 2 proposal for Skyhook, which unfortunately didn't come together in time, simply because exactly what we're trying to discuss today was missing, and I just couldn't get, I couldn't come out with it by myself. It was just not, I just didn't have enough information, basically. So let's see. So the idea is, as I already outlined in the last, the 1 day long computational I/O stack workshop, that I would really like Skyhook to be an ecosystem for the computational I/O stack, where we, basically come up with a blueprint and pieces of that blueprint of a computational I/O stack to the point where, as a community effort, the industry can kind of rely on it, right? There's enough mature open source software tied into that you can say, okay, given this coordination and the proof of concepts and various research results, this seems to be a market we can sell into, right? And this is what happened to Ceph, right? When Ceph entered the market and got to a point where it was a reliable storage system, production level storage system, suddenly it was strategically very important for a number of companies because it actually created a new market and unlocked a market that was previously not available to component makers. So I think we can do something similar with this. This is the big picture, really rudimentary, but we basically have an application level on top, the processing level, where we have, also applications, but they're kind of distributing processing of data, using frameworks that are independent of the actual application code, like Spark and Dask and other processing frameworks. They are using the networking layer to, do the communication between workers and getting data, moving data around. And then there's a storage layer, which is a storage system that is managing the data, making sure that data doesn't get lost, even though devices might fail or even servers might fail or whatever, right? Any kind of failure, basically making sure that even though you have hardware that fails all the time, data doesn't get lost. And then there's the data itself. And so networking and storage arguably is closer to the data than processing layers. And the big deal in actually, what we're trying to do is moving computation closer to the data. So moving computation into the networking and storage layer. And the big challenge is, of course, is that computation requires context, right? So you need to be able to understand the data and the data needs to be complete in order to, execute an operation on the data. And so that's the really sort of an abstract level, the challenge of moving computation closer to the data. So the problem that we're trying to solve is moving data is expensive, right? And so there are 2 ways of reducing data movement. One is caching, very well known, very frequently practiced. And then there's computational offloading, which is often a alternative to caching, because for very large working sets, or where essentially the data only gets looked at once, this is actually true for quite a few application domains. So for instance, AI training have some of that training data usage has that property. And so, you know, the idea of like computational offloading, again, moving computation close to the data, but the data location is managed by storage and networking layers. It's not managed by the application. So that's the challenge, is when we want to move computation close to the data, applications doesn't have a sense. And also the processing pipeline. I mean, there are some exceptions like Hadoop, for instance. They use special purpose file systems like HDFS that discloses the location of the data. But even that can actually go wrong because locations change dynamically as failures occur. And so that location information can be actually out of date given the current status of the storage cluster. So in order to actually embed computation in the storage and networking layers, you have to sort of integrate with the management of where the data is located. So the key thing here is, you know, this has been an argument that's been around for quite a long time, and the electronic component industry has also is very interested to help out, and actually is helping out already, but only in very proprietary, secret ways, driven by the commercial cloud. So they all, you know, all the commercial cloud providers have this implemented, but it is the secret sauce of their stack, and it is not an open. There is no open computational I/O stack across those clouds or those commercial clouds. So the key thing here is, you know, having. I get to that. So the important trends now that makes this particularly urgent that we have such a stack is that special purpose hardware accelerators are the future of all everything that you know needs to go faster. We're increasingly relying on special purpose hardware. CPUs are not getting faster. You know, GPUs, DPUs, TPUs. And the list will likely get longer and faster. The arrival rate of those special purpose hardware accelerators will get faster as we, you know, because every special purpose hardware accelerator is just a one-point solution, right? So we need to get for another acceleration, we need to have yet another hardware. And the other important trend is that storage devices have become really fast, and in order to actually drive storage devices, you either need very expensive CPU motherboards or CPU chipsets, or you know, you need to basically find ways to offload computation from those CPUs. And that actually has a number of advantages, especially when you use special purpose hardware, because you can actually do this at lower cost with having potentially lower latencies and lower energy usage, energy consumption. All these things are really important. Then there's also another trend, is that as the usage of the cloud becomes or grows, you know, the workloads are infinitely different. There's basically no correct system. And so the cloud is really moving towards disaggregation, which means all the resources that are comprising a system can be dynamically composed. So there are memory banks, there are GPU banks, there are storage banks, CPU banks, right? So all these things are essentially connected. And that is, again, enabled by very fast, low-cost Ethernet networks that are becoming available. Ethernet has been always, you know, significantly lower cost than any other kind of network. And they are now becoming really fast. And so you can actually start having even slower memory banks connected with Ethernet. So this is like, actually becoming realistic. And then the last one is the edge, which is the things that are, for telecoms, the little data center that meters all the telephone calls in a town, or maybe a set of cell tower masts or whatever, right? These are all little data centers that are distributed throughout the world, and they actually now with Internet of IoT devices, there's so much data that's being generated that it actually surpasses the data that can be processed in data centers. So the term data center is actually not accurate anymore. It's not the center of the data. The edge is the center of the data, or there is no center of the data, right? So you need to find ways of processing the data at the edge, and there's all kinds of distributed computing opportunities, including machine learning, that facilitates that, where you kind of create local models, and then you kind of combine the local models into like a central model. Things I don't know much about, but it's essentially very important to provide sufficient computational resources at the edge to basically reduce or be able to make the data volume manageable. So that kind of creates actually a fractal picture. You have this problem of moving computation closer to the data on all levels, right? On the global level, so you move computation towards the edge. You have it on the system level, where you're trying to move computation not only from the application but into the processing layer, and that the processing layer is trying to move it into the networking and storage layer, which might be all systems still, and then they move it into the devices, right? And so from like the very large global to the device level, everywhere you see the same kind of pattern. The Skyhook Data Management project started out as a way of leveraging our programmable storage research to accelerate open source database engines or management systems like Postgres, and that over the years turned into the discovery that we can actually just embed Apache Arrow and Ceph. And so that's what Jajit basically did together with Ivo Jimenez. They kind of discovered that a lot of what Jeff had implemented basically kind of maps in a much more cleaner way and much less maintenance intensive way onto just embedding Apache Arrow into Ceph. And that actually allowed us to actually contribute that to the Apache Arrow community. I get to that in a moment. But basically, what we also found is we're not done yet by any means by having done that, right? That enabled us to actually look at that and what actually happens when you process data in storage. And we were initially aghast how little value it provided. And then we realized, the really important things are things like reserialization. The protocols are actually really important, and that has sort of driven the current research into that. And the basic argument hasn't changed. It's just that what we thought was the technological solution just opened up new questions, which is a good thing if you do this in research, right? It's good for research. So the unique thing about this ecosystem is that it sees the creation of a computational I/O stack as a co-design effort of industry, industry component makers, as well as various open source software projects. It can then function as a conduit to put advances into practice, right? And so this is actually, has been tremendously helpful also in the Ceph project, that once you have an infrastructure that allows you to prototype and you have a community around that helps you actually accomplish these prototyping efforts, that really speeds up research. And it also speeds up, real, innovation that can actually result in like startups or whatever, right? And so it really fundamentally, this, I think, could be an alternative innovation path that both includes the research community and also, an independent entrepreneurship and unlocks new markets, right? Again, today, there is a lot of innovation within the data center, but that's not open. It's not shared. It's the secret sauce of data center, data centers of Google, Azure, Amazon, Meta, all these big hyperscalers. And they are big enough that they can just go to these vendors and say, I want to have 1 million of these special purpose devices. They're derived from this and this product. So just make them, and they will. And then it's like firewalled off from all the general available technologies, and nothing gets published about it, or it's not available to the community. So the goal is to grow a contributor community, grow a user community around this Skyhook data management effort, and then transition to a long-term governance and sustainability model. The current status is we have a number of, we have actually 2 pretty well-advanced prototypes. There's the Apache Arrow contribution, the Ceph plugin, as I mentioned before. There's LAML's C2 early functional prototype that basically implements SQL query processing in their HPC stack. We have also prototypes in SNIA National Labs that are Feodel-based, but they're not really sort of at a stage where we can really reuse it. But we have research collaborators, right? We have Seagate. We recently started actually collaborating with Intel as well, Intel Labs. We collaborate with SNIA National Labs, Argonne National Labs, Los Alamos National Labs. And then we are also talking with Kioxia and Samsung to have additional collaborations. And the main research efforts are really about protocols. So Jajit is working on, figuring out why the Arrow flight protocol is so damn fast, even when compared to the latest HPC RDMA hardware accelerated protocols that Argonne maintains. Then Jinshin Liu, who just graduated, looked at opportunistic query execution, and that is sort of taken up. He just started that basically at the end of his PhD thesis, and then Aldrin took that up this summer, and it becomes sort of a major effort on his side. That is essentially this idea of when you query data, the devices that can actually execute these queries can decide on their own whether it would make sense, and they have the resources to do that locally. And then if not, they basically just push back that call for query execution and say, nope, here's the data, I can't do it myself. And so looking at sort of this local cost-benefit modeling, it's actually works surprisingly well in the context that Jinshin looked at. And then the the big unknown, at least for me, is sort of how much can we leverage ongoing standardization efforts like NVMe version 2 and CXL efforts. There's tremendous interest in those, but those are really low-level protocols, and they provide a lot of opportunities to do extra stuff. Like NVMe has, you can introduce new commands. CXL IO has ways of directly addressing accelerators, but there is no upper stack, if you will, right? There's no software. It doesn't work yet with Spark, or it doesn't work with Ceph or whatever, right? It's not even clear where that software should reside. So that's, I think, also a kind of a mission for or possible mission. I mean, I think it's very important for Skyhook, for the Skyhook community to kind of figure this out and find the pieces of software that helps to help integrate this. So the vision, this is my last slide. The vision of SkyhookDM, as I see it, this is the current discussion, is it would be really cool to actually come up with a software map similar to what Paige presented for Pangeo. But I'm not sure that, there is actually, I mean, there might be a lot there. But that's actually work, right? That work hasn't been done really. And it would be really cool to sort of maybe brainstorm today, what software is there, right? And then what's the governance model, right? There's so different models. Pangea has what they called a board or council, advisory council, and it's a very straightforward model, right? You have like an initial advisory council, and then you vote. You can vote people in, you can vote people out. People can resign. People can nominate themselves or nominate other people, and that's a sort of a governance model that has sort of regular meetings, and there's this kind of what I like is good language about institutional partnerships where you acknowledge and kind of also reveal any kind of corporate affiliations and interests, but that basically everyone who is like part of that advisory council is acting as an individual. And actually the governance of Substrate is following also a similar model. And then, the maintainer funding question. So we definitely need people who kind of lead this effort of coordinating all these efforts, maintaining sort of a coherent picture of SkyhookDM software, or that software that's relevant for SkyhookDM, and that could become sort of the part of the computational IO stack, and eventually will be sort of all the components that you need to build maybe your own Skyhook stack, right? Paige calls us, here are the pieces that you can use to create your own Pangeo, right? Like that. So it's essentially they're trying to address basically scalable data analysis in a particular discipline, and in her case, earth science. And so we're trying to get essentially the pieces together to do a computational IO stack. Yeah, and so the funding conduits are cross and funding calls like NSF, pathways to open source ecosystems. So that's it. So any questions or reactions to this? Any ideas of how the software map should look like? And it could be, maybe I'm going to also throw up a alternative view, a software map that Paige put out there was more like a traditional software map where you basically, you have like a two-dimensional picture and there are like these different sections and they are kind of showing you where in the stack what software is. Some of it is storage software, some of it is processing software, some of it is visualization software. In our case, you would have, what would be the categories that you have for software, like protocols, data management libraries, some abstractions, different, data location. If you look at sort of, for instance, the Mochi ecosystem, exascale data management ecosystem, they have quite a bit of software for creating really fast pipelines between HPC applications, but they don't have the sense of, okay, here's sort of a data storage location software like Crush and Ceph, right? So you would have to, they have a key value, they have local key value stores, but they don't have anything global to actually store data in a global sense. So each of those pieces have sort of some things that Ceph doesn't have, and then they also don't have things that Ceph has. So there's like, and so, yeah, so how do you create a coherent picture out of that? But you can also look at it in a different way. So let me just get out of this thing and look at an example where bear with me for a moment. Yeah, here we go. I don't know where I put that. Oh, wait. Yeah, I have it here. So one project that I looked at fairly carefully as sort of a blueprint also for SkyhookDM was another project that is maintained by Harvard University, and it's called the Open Differential Privacy ecosystem. And so and their kind of description, the picture that describes their project is more like a process than a map, right? So this is, can everybody see that?
Yeah.
So it's more like a process, right? So you have like basically in this case, it's basically important that when you do open differential privacy, that you use the latest algorithms, you incorporate or you address vulnerabilities as fast as possible, and it's kind of vetted, right? Vetted by experts so that other people can trust that code. And so they have kind of introduced that. But then there's like this succession of other systems, right? And so they include parts of the vetted core, but not necessarily all of it. And then they combine it with new code, right? And so there's essentially a clear idea of what part is, is something external to the vetted core and which one is actually part of the vetted core. So that's and so basically this OpenDB software ecosystem is essentially a way to see what you can do with the library, but also, enable other people to create new systems with the OpenDB library. And so that might be also another way to look at SkyhookDM, right? It's again this idea that you have these pieces and you kind of put together these new special purpose computational IO stack systems or pipelines or applications or whatever you want to call them. So any reactions?
So for like previous things like Genshin's work and like Jajit's work, like, do you have like a concept of where those fit in, like with respect to each other? Right, like I guess part of what I'm asking is, you want to we want to get to a place where there's a roadmap, right? And there's work that you have done, and there's, clearly some overlap of like the open source libraries that have been used. And there's like some ideas of like, this work is for these use cases. So like, I'm just wondering, like, have you contextualized those things, together in a single map?
Yeah, so let me just draw something. I have a whiteboard here, but I have to get a pen really quickly. I'm right about that. So in a very high level way, so let me just see whether I can actually add a whiteboard here. Share content, whiteboard, here we go. So it's basically, the client, oops. Let me just that back. Okay, client application. And then you have a protocol. And then you have
Carlos, are you trying to show that on the whiteboard for Zoom, or it's not coming?
Yeah,
it's not coming up. No.
Oh, I can see it.
Oh, I can see. Oh, wait, I'm sorry. My screen's all screwed up. All right, that's probably my.
Okay.
When you switched over, it didn't pop up right on my screen. Sorry.
Okay.
All good.
So client application protocol, right? So, and then there's basically kind of very abstract network storage layer, right? And so the way the layer is that this could be basically either like a storage server, or or like a SmartNIC, right? And then this there's basically at the end there's some kind of object with some operations, and the location of that object, the object could be basically somewhere on a SmartNIC as part of a data stream, or it could be in a storage system, and the location of that object is managed by the network and the storage layer, right? I don't know exactly how to present that here, but this is basically so Jajit at this point, the Ceph plugin is an example of putting essentially Apache Arrow into the object, right? There's not much else there. It's basically the query will always be executed in that object, no matter whether the server is overloaded or not, right? There's once you decide, okay, I'm gonna filter data in this object, then you just do it, right? So the question of this, so it's the you can basically say opportunistic execution. And again, this is network storage layer encompasses either processes or devices, right? It's sort of an abstract way. And this opportunistic execution, that basically says, okay, if this protocol basically allows me to query something in this data, like an SQL query or something, this layer can say, has the option to not execute that, right? So that's, I think, what you're involved in. And then the protocol itself is what Jajit is currently involved in. But there's also more. There's basically this idea right now where we go below the object, right? So there's the object on the storage network layer, but then there's basically the actual device. And let's call it storage device. That stops working. Somehow. I lost the ability to. Am I still on? Yeah.
You're still on. Yeah. I still see your whiteboard, but I don't see updates, which I think is what you're talking about.
Yeah. Huh. Let's see. There's something. Okay. That's too bad. I can select things. Okay. Why did this work and now it doesn't work? Or maybe oh, here we go.
I see you erasing at least.
Yeah, so erasing works.
Right. Well,
So,
that aside, so I think
there you go. Now I got it. So I was just going to say devices are sort of on the lower layer, right? And so there's now work, for instance, that we have with this is protocol. Sorry, my handwriting is terrible. So devices there's basically this idea that maybe these devices have only a block interface, right? But there's like these new ideas that Intel, for instance, has that when a block device and an object interacts, you can actually still do that by moving computation down if you can tell the device the particular vector of blocks that operation works on. And as long as the operation basically only has all the data and enough information to make sense of these sets of blocks, you don't need more. You don't need actually a key value interface on the storage device, but you can just have this kind of a new way of just grouping blocks, or it's like a vector of blocks. And so that's sort of like a new idea that will simplify essentially the the demands for a block device, right? So it's easier to implement that functionality than to create a whole key value service on a block device. But it also has disadvantages because now the device doesn't actually have an idea of what those block extents are, or whether they are stable or not, right? So that's the advantage of a key value device. It's like once the device knows, okay, this is a key and this is the value, it can organize itself so that retrieving that value as a whole is fast, right? And there's never any other way of receiving or of getting that piece of value than in that key value abstraction. And this is like the big problem, right? Or this is the big advantage of key value stores, is that you can sort of manage the data and put the value of a key value pair always in one thing. So because you know you will always request all of that. And in a block device, you know, the value can span many blocks, but how those blocks relate to each other is completely unknown to the device. And so that's essentially the difficulty of laying out the data in a block device. It's sort of it basically just uses time, right? As an indicator of how these blocks arrived at the device to estimate how they will be accessed in the future.
Yeah, I think, you know, on that note, like there's some tricks that can be played with, like, you know, here's the semantics of a key value interface or a block interface. Like ultimately that's like, you know, those semantics are guaranteed by some service that interfaces with the actual physical device, right?
Mm-hmm.
So I think to some extent, I think it's not relevant almost to a roadmap, or like it's maybe something that you want to say like your roadmap maybe accommodates, you know, in some cohesive way, rather than focusing on like, you know, some of those details. But if I can share my screen, I have some diagrams that I think kind of lead towards what you want. But you'll have to stop sharing in order for me to share.
Yeah, I know. I'd have to figure out how to do that. Let's see.
Yeah, so I'll just show some diagrams that kind of like are things that I've thought about in terms of like this high level thinking, and hopefully everyone can see. But basically, like, so here, like I kind of have like 3 scenarios, right? Which is like the progression of like traditional databases and data management systems, object storage systems, and then kind of like where we're at now, right? And so traditionally, right, you essentially have the catalog, and then all the table data is basically just like, you know, you're storing it in a very specific way, and you know what that storage is based on what's in that catalog, which holds like table schemas, right? So because the schema is like managed by the database, you have to go through the database to access that data and understand it, right? So what I'm saying is that with traditional database, semantic access has to go through that database, right? And then the storage is just storage. With object storage like Ceph, right, they push it down a little bit, which is to say that, like, you know, maybe you know how to name an object, right? And then the Ceph system says like, well, this object, you know, parts of its data are stored here or parts of it is stored there. And then you can like couple like some logic with that object access, right? So basically each server can now run a function and do semantic access, you know, so each OSD, right? And so like you push it down a little bit, like it's a little bit more like, as long as you can get to one of these OSDs, you can do semantic access from that. And then kind of like where we're at with computational storage is like, you're saying we're adding compute resources to like this low level device. So every device itself should be able to do semantic access. Like that's kind of the goal, and something that like previous systems haven't really accommodated because they've never had devices that they actually wanted to push any of this logic to, right? So all of this to say, like, this is so like, and I guess I can contextualize with what you're saying with Intel versus key values, right? Like Intel is basically saying like, if you push down the semantics, then even though this is just block storage, like it can do all the work as long as like you know how to do the block semantics, right? Which is basically saying like, if you blur the lines between key values and these blocks are all part of the same key value, then we can do it. But you just need a lower level interface, right? But ultimately, I think a key thing here is like, where is semantic access, and like where are you allowing components of your system to do that work?
Right.
And then,
so what would you
kind
think, what would you think, given this picture? Well, okay, let you finish first. But I was just going to throw in a question. You don't have to answer it now, but this, somebody who has to, build a system, puts millions of dollars, billions of dollars sometimes into, not billions, but hundreds of millions of dollars into like creating a new device, right? The challenge for them is to make sure it actually works, right? People can use that device, right? People have that software. And so that's I think where I think the Skyhook data management ecosystem can sort of, like that you can actually, we would help then the industry say, your customers can use this software that works. It's, and it uses mature components like Substrate, like Apache Arrow, like Ceph, or whatever, right? And or in an HPC context, Mochi, so that they can sort of confidently say, okay, there is a market for this, people can readily use it. And I think that's where I think we're, and then the other thing is that right now you have actually CSDs, like SmartSSDs, right, from Samsung, but their first version, didn't really consider that there's all of these very cool open source software projects out there. In fact, their second generation is sort of saying, okay, we're working with the storage standards like CXL and the computational storage SNIA working group and NVMe 2.0, but it's still not, yeah, great, but you still need to actually have the software stack to use those new protocols. So it's still not clear, who can adopt that. So
I think the short answer would be like, at this level where you're thinking about the devices, it's less about, it's not entirely about like what software is available. It's kind of, you want to think more about like, what does it take to do semantic access? It's like, you need something to describe, either the data is self-describing and you need to do this complex work of like access some data and then understand what it is, or you do like the relational approach, right? Where like you have a schema and then the data is like laid out by that schema. And so you need both of those things in order to access the data in the way that you want to access it, right? So it's like, how do you do those? How do you accommodate all of that information you need to do semantic data access? So, but that's short answer. And then I'll kind of go to this other image, this diagram here on the left, right? Which is like, if you, and this is like query processing specific, right? But if you break up, like, what are the libraries doing and where do they fit in this ecosystem, you can make it a little easier to figure out like, where is the work that your libraries are doing? And then what libraries is it interacting with? And then, for query processing, right? When I talk about semantic access now happens on a device, that means that if query processing is something you want to do as part of that semantic access, it, is something you want to be able to do on a device, right? If you don't want to do query processing, on that small of a scale, right? Then like that affects basically, some other things. But I'll break this diagram a bit down, right? Which is to say that like, if we take this yellow box, like this is a logical workflow that is basically like data flow processing, right? Like other libraries like IBIS, which is for Python, or dplyr, which is for R, what they do is they try to generate a plan, which can eventually become this yellow box, right? And then SQL also generates that, or like some libraries try to go from this back to SQL, right? But then also you can do optimization on this plan, or you can pass it to something that's just going to execute it, right? So like when you're talking about substrate, like substrate is like a way to represent things in this yellow box, right? And then a plan executor or a query engine would be something like a Arrow. Like you can give it this plan and it'll execute it. Like it needs to do some interpretation of it in order to do that execution. But like that's its role, right? And so it's kind of like if these are all the things that are working together to do query processing as a whole, right? Like where is, so I know that like Genshin's work is kind of like in between substrate and like this query engine portion, right? Because he's using Arrow, I think, to say like what's in a query plan, and then how do I decide where to execute it, or whether it should be executed or not, right?
Yeah, it's not weird, but yeah, exactly.
Yeah, so some of my work is more like, I have this query plan. How do I get it through the system such that like, I can break it up when possible. And then like, how do I stitch together like heterogeneous engines to cooperatively like work together. Right. But then like, when you talk about like the other things that work in that open source data ecosystem, right? Like, Snowflake and like DuckDB, like they're doing a lot of these, right? But like, for instance, if DuckDB is taking in substrate, right, then like all of this portion before the yellow box, you're basically saying, I'm going to do it in some other library. And what I'm going to pass to DuckDB is the equivalent of this yellow box, right? So like it's, you start to like break down, like not only where do you fit in the ecosystem, but like which portions are covered by multiple tools, and then why do you think you need to cover either a larger portion or a smaller portion, and why do those things need to be in some devices and not others?
Yeah, I mean, fundamentally, I think that both Apache Arrow and Substrate and maybe also Polygraph actually, in some sense, right within runtimes, within a particular stack of a runtime, are these pieces that make this composable, right? I mean, I don't know of any, maybe protocols as well. Well, yeah, that it is all protocols, but sort of on a lower level, whether you use RPC or gRPC or RDMA or whatever. But it's basically these two things like Apache Arrow with their record batches, which is, this, no matter what runtimes you have in your stack, it just works, right? Because you have and it works really efficiently. In representing the data that you ship around, and as well as basically the query plan idea. And then, more recently we had this by Adam Kennedy, this talk by about Polygraph, which is their way of saying, Substrate is really unwieldy for representing query plans efficiently and making the manipulation, annotation of your query plans also very efficient. And so they suggesting basically just use Apache Arrow tables again to represent the query plan, and which you can do if the goal is not to communicate, do this end-to-end communication between completely different systems, but if it's sort of a more scoped effort, right, where you can sort of agree on what these additional columns in a query plan table actually mean, and there's sort of more internal ways of communicating within the stack, and that's for instance, I think where that might be also a role for Skyhook DM create conventions of, of how those efficient representations of query plans look like. So that's the first time. Before I saw Adam's talk, I never considered that actually substrate would be inefficient, right? It could actually be a significant slowdown of your system. This is supposed to go really fast. and having to deal with like a hierarchical, unwieldy representation that you want to manipulate might actually cause a lot of copying by itself that might kill your performance. So
yeah, I mean, so
that I thought was really enlightening, and I think, but yeah, I mean, I think what you're saying is essentially there are these frameworks that are, lucky for us, very fairly, I mean, substrate maybe not as mature, but as Apache Arrow, but Apache Arrow is very mature at this point. And so what people have not done is to really put them together in this way where we can sort of say, okay, we use these things that are already commonly used in the processing layer, right? The data processing layer. We will use them deeper in the stack, like in the networking layer and in the storage layer.
Yeah, and I think, well, I think before I tackle that, so I'll say also, like, but if you understand like what some of these libraries are doing, it can make it easier for you to say like, what things should you put in your roadmap, right? So like when you talk about polygraph, right? Like the reason substrate is inefficient is because polygraph wants to do query optimization, but substrate doesn't have a query optimizer. No one's written a query optimizer for substrate, right? And then, you're right, Arrow does make some things more composable, but the reason it makes it more composable is because the Arrow handles the query engine portion. The Arrow data, like format specification, is basically like when you're communicating along these lines, like what is that format, right? And then like when you're talking about like the storage engine, right? Like they can interface with things like Parquet, right? In which case, like if you are doing something like DuckDB and you're storing files in Parquet, you no longer need Arrow to do that part of, your overall composable system. But maybe you still use Arrow for like, the data movement between like these components, right? So it's kind of like a library that is composable just means that it covers less of this and says, I know that because I cover less of this, these are things I need to interface with, and I'll do them, right? So it's kind of like, if you're talking about Skyhook being like, we can work, with these heterogeneous processors, right? Well, then does that mean you're working with multiple query engines, right? Or does that mean that you accept just substrate or like other formats, right? Like, are you accepting like actual SQL strings, right? So like understanding those things would help you, I think, construct the roadmap.
Yeah, and you remember, Adam basically suggested that they would love to work with us to help really, move their polygraph efforts beyond just their very particular use case, right? So that, yeah, I think that, and it might be really cool to just look at that as sort of a sub research project, right? It might be a master's project, it might be something we list as a possible master's project or master's topic, master's thesis topic, to just look at the difference between processing, take like a query optimization. And query optimization, by the way, could also mean that, just partitioning the query plan, right? So that might be also a kind of a form of query optimization where you're not reordering the query, but you actually deciding where to actually execute what part of the query. That's in some sense also part of query optimization. And actually, let's just take one of those scenarios where you have opportunistic execution, right? And see what does it actually mean when I push something back and I have to operate on the, let's say, the binary representation of substrate versus Apache Arrow tables, right? And using essentially polygraph's approach to just communicate the various annotations of the plan via Apache Arrow tables. So
yeah, I mean, some of that is probably lower level than I think what you want to discuss right now. But I mean, just to say that like annotations on a query plan, like that doesn't require polygraph, right? It's just
yeah,
like
yeah,
that's purely like how you communicate query plan.
Yeah,
but
yeah, I think, I mean, this is the, you know, I think there is so much, and you're right. I mean, there's so much, you know, things that we still need to understand how things kind of belong together, and you have to, but I like to sort of get to a point where we have a map, right? And I think maybe, you know, what you suggested, that could be a map, right? So where we can at least have a diagram where we can sort of point, you are working on this, you're working on that, right? And so, and maybe your diagrams work better for that, but it's basically this picture of the different pieces that we identified as worthwhile to work on, you know, and there might be other pieces as people sort of discover more, right? So it's just like Sajid. Sajid wasn't really interested in protocols until he had actually a full functioning Ceph plugin and actually was starting to do the experiments and realized, wow, the serialization overhead is a bummer. So, and we will never get beyond those numbers because of Ceph's inflexibility with the protocol, right? And so, so that's sort of yeah, that's, I think that might be the sort of the next step of the so-called software map, right? And I think then you can also start to articulate, you know, a roadmap, because once you have that sort of this picture, you can actually at least say, you know, okay, the roadmap might be not complete. We don't really know what, but then you can sort of start discussions with other stakeholders and say, you know, what would you like to have in here, right? And actually, in some sense, we're having that discussion with Intel Labs, right, where they basically say, yeah, that would be really nice, but you know, why don't we start at this corner here and make sort of this minimal assumption, see how little we actually have to do to a device to actually make this possible. And I think that's very smart, right? That basically is the kind of thing that that can then feed into a standardization effort.
But yeah, if anyone else wants to chime in, I didn't mean to.
Sajid, maybe you can talk a little bit about the effort that you have with Intel Labs, because that's sort of more recent.
Well, I think Emily also, like, at least seemed like she was ready to engage. So if she had any
I didn't
input,
see that.
I just kind of wanted to, you know, ask.
I didn't see a hand up or anything like that, so that's fine. But
I don't really have anything to contribute, like, technically, because storage is like just completely not my area. But in thinking about a roadmap, I was just gonna ask, like, do you know where you're trying to get to that you could like work backwards from, like, or if that's like maybe a helpful way to think about it. And there's so many different pieces of that, right? There's like the technical piece, which is over my head, and then there's also the sort of piece of like, who are the people that are using this software, that you want to be using the software, like how do you reach them, and then like who, like the sort of user contributor like Venn diagram of, you know,
right,
how, like growing a community around it. But I think that I don't know, I guess it's just everyone thinks about stuff differently, and that's how I like find it helpful to think about, is like, well, where am I trying to get to, and like, okay, what are the steps that need to happen between now and then, and they're probably going to change, but
Yeah,
those are things that I find
that's
helpful.
exactly the work that I hope to accomplish, right? Because it's when I wrote this proposal, and I had sort of like all the pieces in the beginning, the pieces at the end, and then there was like the centerpiece, which is like, okay, what are the goals? What's the vision? And then it was, that was the weird part where I sort of realized, yeah, I can write something, but it's not very coherent, right? Because we kind of more recently arrived at this more more inclusive way of looking at Skyhook. It used to be something much more specific, and I think that yeah. So I think that identifying essentially, so there's basically work that we can do, and we can write down, right? So what are the different communities? And you can see that already, right? The people that are participating in this effort. There's going to be
the one other thing I would add that comes from just like a lot of like work, like teaching workshops with like new technologies that I've done in the past is like, I think I have no sense of like how big your community is right now and like how many people are like working on this. But I think that even just like starting by trying to bring in like a few more people to work on it means that there will be a few more people in the room that have like opinions about what should happen. And like, they don't even have to be opinions that you agree with. They might actually help just clarify for you, like that you want to do something else instead. But I don't know, that's another thing that I find really helpful, like in the past, like prototyping things is just like get people using it, even if it's like broken and imperfect. And then it gives just a concrete starting point, like you're saying, Carlos, to sort of transition from the abstract like vision to like, okay, but what does the next step look like, and who's going to work on that?
Yeah, so we have, and that actually we're not even there, right? So we don't actually have a prototype. And we know already that the prototype that's the most functioning one is not that a lot of the stakeholders can use. Because it's just, it might be interesting for other ones. And so this is like the thing that we just don't have enough people, but it's something that we have to somehow bootstrap, right? Is this thing where, so we have this contribution to Apache Arrow, and we were like totally, we're so happy about that, right? And then suddenly the reality hits us, well, we need to maintain that. We need to actually create all the documentation of that. And it was very clear that Jajit shouldn't be doing that. He already wrote the papers. He needs to move on with research. He needs to get his advancement ready. And there is no one else who can actually write the documentation, simply the documentation of the contributed thing. So you go to Apache Arrow today, right? And it's all there. It's all maintained, it works, but there's zero documentation for it. And so we wouldn't even like people who would, there's like one person, I think, correct me if I'm wrong, Jajit, who actually opened an issue like a few months ago, right? And wanted to get something working, and Jajit, took him like a day to fix it, and that's it. And so that's the most mature part of the code. Right. And then I don't know, Aldrin, do you have concrete users of your work? Right. That's sort of like the status of the project. It's like there's like all these ideas, there's collaborators, there's like, but if we're not,
the bottleneck is just like people to implement or work on it, or what do you see as the bottleneck right now?
The bottleneck is to actually have someone who really works on connecting people together, right? And so I'm thinking I really like to hire Philip. Philip Kuhfeld would be the perfect person. He knows everyone in the industry, anyone in National Lab, right? And he knows all the students, he knows technology, and he doesn't currently have a job. So I like to really hire him and do this, but I don't know whether he wants to do that right now, right? He might be, so that might be, but I really need a person like that to have both the expertise, the connections, and also the willingness to really get to that point where we have a coherent picture at least, right? And then we can sort of identify the things in the roadmap. It's like, in order to get to where people are starting to pay attention, we need at least this minimal functionality, right?
Yeah.
And so that was like, I mean, going back to my experience with Ceph, right? That point in storage system was actually a really difficult one, because it meant that you had to both make it really reliable so you don't lose data, which is really hard because you can't have any software errors, basically. And then the other thing is you needed to have something in the Linux kernel. And that was a 3-year project, right? Just to get the client for Ceph into the Linux kernel, get it, be part of it. And that suddenly was a huge boost, like everybody, and that's to this day, actually, Joel told me that yesterday, is to this day, the reason why nobody can touch Ceph is because it has a Linux kernel client. And I didn't even know that, right? And so it's like, and that took like somebody like Sage 3 years, and he's like an amazingly fast programmer, right? So to get actually to the point where that was pulled into the Linux kernel and was like officially part of the Linux kernel was really, really hard work. So, I hope we don't have that, because we, it would be hard, right? It would take years. But my hope is that there are other pieces that we can add that where people will make attention. I mean, it's already unique enough, right? But it's also maybe because of this completely green field of like, how would a storage stack look like that, right? That makes it difficult.
Yeah, I guess like one thing I was wondering, and it sounds like maybe this doesn't address what the bottleneck is anyway, but like one of the things that you described that needs work is like the documentation. And I guess I was wondering if like there's any pieces that could be chunked out to be like a master's student project, or like as I understand it, like, because I think there's a challenge when projects are like this young to get buy-in from people without any kind of like incentive, who aren't the people who are conceptualizing it. Like if it's your project, you're invested because it's your project. But I think for other people, it's a tremendous risk to invest time in something that isn't their vision. Like they don't really know where it's going. Like they might not be around long enough to see it reach its like endpoint. So I guess I was just thinking, like, I mean, if it's even useful, are there ways to sort of like leverage structures that already exist to offer people incentives, whether that's like having students do contributions for credit as independent study, or I don't know, James talks a lot about how master's students are like always looking for projects, and I've seen some faculty post like on their websites like, here's 5 months
we have
projects ready to go.
We have and I did that actually for Farid, right? So I can actually post master student projects, and there is a consolidated list, and that actually starts to actually be more popular because it's been really more and more widely advertised, and it actually really works. So Farid found actually a master students very quickly, simply by posting essentially that website to Twitter or to LinkedIn or whatever, I forgot. And then right away, there's like students. So it's so I think that's it's just that who's mentoring those students.
I mean, for sure. Yeah, it's not lost on me
that's the bottleneck, right? So
work.
I'm not in a position like Oscar is, right, with his projects, because that's what he does. This is not the only thing I do. If it's the only thing I do, then
Totally.
So I'm kind of missing a person here. So I totally get that point. So and the thing is that, then, immediately the funding part comes up, right? So that's the, and I think there is like this step where, you know, I want to get and time is of in some sense of essence, right? To get to the point where right now everybody is really starting to get excited about computational I/O stack. There's all these new protocols coming online, but you know, sooner or later people will really want to see that software stack to be done, and so I think there is a real opportunity now to get, you know, cross-spec going, to get membership fees or some kind of, you know, what we discussed basically, right? And so and I think then, you know, have, you know, a stronger posture for next year's pose a phase 2 proposal that we can, you know, we can use to be successful and have actually funding for those positions. But yeah, so that's, yeah, go ahead.
Oh, I was just gonna ask, like, I don't know the extent of, you were saying there's like collaboration sort of developing with Intel, I think. I was just wondering if there are any industry partners who would potentially have this in the future as something that would be beneficial enough for them to, like, I mean, just directly fund.
Yeah.
You know, someone like, I don't know how he does it, but like, I know James, my advisor, like, he had no advice for me on NSF proposals, but he's got a lot of money from industry. So, you know, I think that comes with like different things that are frustrating in different ways, but he's been pretty successful in like partnering with companies to invest in like having a dedicated grad student to work on like one specific project or something like that. And I feel like, I feel like as a grad student, like, it's nice to have freedom, but that's not like an unusual model. Like, a chunk of my PhD was funded by a very specific project that was meant to be my focus. So
No, and I think that it's happening. You know, the weird thing is we have right now, basically the Mochi collaboration that Jajit is doing is unfunded, right? The IRIS-HEP collaboration, which is the collaboration with the high energy physics people, that's funded for another year. There's the interlab collaboration, which is going really well. Well, they said, let's just start something, and if it works out, we fund something, right? So that's sort of he said, so the irons in the fire, so to speak, and that's often what it takes to be to get sort of industry funding, right? And but industry is very tight right now. It's really hard to get funding, and you know, they have huge layoffs. Nobody knows what happens next somehow, right? I think there's sort of this generational change also. So, you know, we definitely saw that, you know, the things that used to be really attractive to industry and cross are not really that anymore. And so that's one of the reasons also why we, you know, Skyhook itself was just interesting enough. That was always the flagship project, you know, that attracted all this funding. And, you know, all of a sudden it's not, right? So because industry is now realizing, well, it's a bigger problem and you need to have a bigger scope than just for this particular solution point within Ceph, within the Ceph ecosystem. So that's one of the reasons why, you know, we're making broader, but that also has these new challenges. So, but I think I love your points. So this is great. I think that, you know, really articulating, you know, where we want to be is it's sort of like this. Yeah, I can't tell you how many meetings I had by now with that exact question, and every time it's sort of a little closer, but then something comes up, and so it's been sort of so far it's been elusive in some sense, but I'm also not giving up yet, because it seems like tantalizing close. I
Yeah.
know I sound a little mad, and but there are these like Pankaj, for instance, right? He has now this interest group for CXL, which is like those one of those very promising protocols that industry's betting on, and and so the fact that those group meetings have a lot of interest as well, so it's something that I want to leverage or collaborate with, and so yeah, you can. It's often just to get the. There will be like a presentation about Skyhook in one of those meetings, right? And if we can have somehow a coherent story of how that actually connects to those efforts, right, then I think it would be a win, and we would get more community members interested in our stuff. So
I think something else that could be like really helpful too, and maybe you already have this in like other versions of the presentation, but is like starting at like a more zoomed out level when talking to like new people about it, and being able to give like a concrete like this is how this is going to functionally impact like how people use technology, or how you use technology, or like I don't understand enough about storage to like make a good example like off the cuff. But I think that can help like draw people in who don't maybe have the technical expertise to like solve the particular problem, but might know somebody who does. But I think I think somebody who doesn't have a background in storage right now like might just miss the whole story, because they don't know how to like it would be helpful to have like a 2-sentence like sort of easily digestible summary for just like general
who cares about the networking storage layer, right? It's something I heard that actually a lot. I don't like I was talking to Irina Zak yesterday, and she said, I don't want to know anything about the networking or storage layer, just keep me away from it.
Yeah, I'm like really glad that there's smart people like solving this stuff, because I don't get it, but like but I think it would be really helpful. And like these are probably ridiculous questions because I'm not a storage person, but like what is this going to change for my life? Is it going to like make like data transfer like faster or cheaper or like more accessible? Like I think that like being able to just put it in that sort of frame for the average person is like
there is definitely material for that. But it's I didn't and in this particular session I didn't want to spend too much time on it, but you're right. It's sort of like this, one idea would be to take essentially the demos that Jajit has and develop as part of the Iris HEP, the high energy physics community. Those are Jupyter notebooks, right? And it's basically saying, okay, here's a data set. Here's a data set evaluated in a traditional way, and here's what you have to do. It's just a slightly different command, but it basically shows you, okay, now you're actually offloading it to the storage system. And, you can sort of see, okay, all the storage nodes are involved in actually querying the data, and then it gets sort of collated back up, and there you have it.
Yeah, totally. I think that kind of thing could be like really helpful for people to understand it.
Yeah, I was going to add that I think the only real connection to storage and networking is like you're now adding capabilities to devices that like software doesn't expect to have. So now there's just like more things that it can push work to that it couldn't do before. But on that note, I don't know if you guys have officially, changed any of the times, but I think technically the wrap up started like 8 minutes ago. I don't know if it's a different Zoom or whatever. So just
no. It's all in the same one, so it's okay.
Yeah, it's all in the same.
Oh, okay.
Thanks for keeping time there, Aldrin.
So I do just want to like piggyback on one thing you said, Aldrin, to make sure I understand, because I think this is like the important piece that I haven't heard yet, which is like that it sounds like because you're offloading stuff or able to offload stuff, like, but that is literally making stuff possible that's not possible yet, right? Like that's the goal.
Yeah. So
So like
In
I
a
think that's,
nutshell,
like, a
it's like
really big deal. like I want that to be like the like top like takeaway like from like it's, I don't know.
like I think that the easiest but maybe totally leaky analogy that I'm just now going to make, right? It's like, imagine like the working age is 18, and then, or imagine the working age is 21, and you're like, well, like, let's make it 18. All of a sudden, there's like this whole age group that like you didn't give work to before, but now you can give work to. And like they're still in school, so maybe they can't do a lot of work,
right,
but they can still do some work, you know? Like that's, and there's a ton of them. There's potentially more of them than there was in the previous generation.
like we
Like
don't
that's,
even know yet.
I love that.
exactly. Yeah.
Yeah, no, I think
That's,
this is like that's exactly what I'm talking about. I just think that like, yeah, to my earlier point, sorry to hammer it, but I do think like there's so many conferences I go to where like maybe I even know like I'm gonna end up in a conversation with somebody who would be interesting to connect you to, but like I mean, like right now the conversation will be like, oh, they work on storage, and I'll be like, oh, cool, I work with people who work on storage.
Yeah.
And then that's as
it's
far as you go.
and then I'm like, I could connect you. Like, would you like me to connect you, storage people, to talk to storage people? But I think it would be like really, really cool if like that's like everyone has this awareness of like the potential of like what this technology is going to do. Because I would love to be able to know
That is, and you know, frankly, that is actually a very hard thing, because storage traditionally in computer science has been, you know, it was always sort of this little stepchild, or I don't know what you call it, right? It's like the ugly duckling, or it's this thing that, you know, nobody wants to. It's like just there, you know. It's like the power plug in the wall, basically. I don't care where the power comes from, right? As long as there's always power. And so it's in many respects that it's sort of, you know, so everybody tries to ignore it, and you know, and panics completely when they lose data, and you know,
they like take it all for granted, it sounds like.
yeah, and it is sort of designed to be taken for granted. It's the purpose is that you take it for granted, right? There is no way you can work if you can't take for granted that your data is still there tomorrow. And so that's the dynamic that we have to deal with a little bit. It's like, you know, we're doing something really cool, but you don't care.
Yeah.
It's like it's under the cover. And you know, the thing that I kind of look back at when the introduction of Dask. So I think the people who introduced Dask, they did something really cool. They had a visualization. And so you could actually see, I don't know, Aldrin, whether you remember those Dask presentations.
I've probably seen it, but nothing comes to mind.
It was like they had, so basically what Dask does is it allows the Python community to process data that doesn't fit into main memory of their local memory. And so you can basically tell it, okay, you know, I have exactly the same interface in how I interact with the data, except you have that keyword Dask in front of it, basically, and then say, how many workers do you want to use for that data? And then it will distribute that just processing the data across these multiple workers, all having, you know, as a sum, more memory than your local machine. That's basically it. And so what the visualization showed is, let's say you do a matrix transform, right? It knows how to actually distribute that process of a matrix transform. It has the recipes for that. And then you kind of see on that visualization, you know, who is working on that. And you see sort of like, as the data gets processed, right, there's like all this activity going through, and it looks very cool. And then at the end, you have like done something that you couldn't do locally. So there's like a extremely, like, everybody was, finally I can do stuff that I couldn't do before, right? And so if we can say essentially, you know, you can do the same thing but you don't need Dask, right? You can do Skyhook. That's sort of like, it's a lame argument, right? Because why we can do it already, right? So we need to find sort of something similar where you basically take like some storage system that just sits there, right? And you can basically do things without adding any additional workers or whatever. It just works.
Yeah, I actually think
that's
that,
hard.
a really good example of like kind of what I'm imagining is kind of what Paige did in her presentation, where she had like the two maps of like the world, and she showed like how like people for the longest time had been restricted to analyzing like oceanographic data in chunks, right? Because like the data sets were like so big, and the way they were stored or whatever manipulated, like that was all you could do. And then she just shows that like she's working with like all of the data, right? Like that to me, even as somebody who like doesn't understand like the nuts and bolts of like what she's like actually technically doing, I was like, whoa, like that's like really cool. Like,
Yeah.
so I think that's sort of,
And I have actually, so I did earlier this week contacted a researcher, and she actually responded, and is super happy about that. It's Anna Klimovich. So she is a Stanford graduate. She is now a faculty at ETH Zurich. She knows Heiner Litz really well because they were both students at Stanford. And she is actually working on how do you improve the AI training pipeline? You know, when you train models, there is often the bottleneck of training is this pipeline, and it's not just retrieving data, but you process the data in interesting ways to keep the data set that you actually have in storage not only small, but to also come up with like variations that you know are going to occur. So a good example is basically you have a large number of pictures, and you want to basically learn how to categorize these pictures with your AI model. But it's not enough to just look at the pictures, but you want to be able to look the pictures in various, rotations, kind of modifications, right? And so those things you want to do on the fly. You don't want to like store each modification of each picture also on storage. It would be too expensive. So it turns out this is really common in this AI training pipelines. So you're basically taking data, you process it in some way, and then and it turns out one of the most promising things is using serverless computing, because it's really hard to predict what you need for AI training. And serverless computing has the promise that you only pay for exactly the computation that you need, and not any kind of packaging, like here's a server or here's this many processors or something, right? It's really dynamic. You pay a little bit more for that flexibility, but in the whole you pay actually less, because it's much more dynamic or much more elastic. And it turns out there's no way to have those serverless computing reach into the networking layer or on the storage layer right now. And so I said, basically, maybe there's, and she's interested, right? So that might be the killer app, where you basically say, okay, here's basically, one of those pipelines, right? And you can basically make sure that the latency or the speed of learning, or the amount of energy that's being consumed during that learning process is lower, because you actually are able to offload those pipeline modifications. And so I think that might be a killer app. I mean, it's AI, so it's anything connected to AI is like automatically a killer app these days. But it's also, I think, it kind of, serverless computing is incredibly popular, right? And there are like multiple research platforms already. So that's something that that I think might be a direction to pursue to say, okay, here's the story. But we don't know yet. That's the thing. It's open, right? So you can't. So there's still research to be done to actually figure this out. So, something that maybe Jajit or Aldrin take up. Anyways, we're way over time. Sorry about that.
No, I was gonna say, I think we're just really wrapping
up wrapping
anyway.
up.
I mean, at this point, it is what we want it to be, right?
We're wrapping up. It's fine. I was gonna say, it's just like, if it's just these people, then it's, you guys the wrap up can be just you continuing to talk about this.
Yeah. So
it feels like everything kind of led to this. You've mentioned
you're the last external holdout. I'm really amazed.
If there's one thing I'm good at doing, it's sitting on Zoom meetings.
So
we appreciate both of you.
Yeah.
Well, also you too, Stephanie. You don't usually sit in on meetings between us.
Sure. I pop in every so often and then go, yeah, okay. I'm kind of like what Emily was saying too, is that like, wow, if I had that little cheat sheet on what things were when you go into a meeting, it's the same thing. I'm all like, I know, yeah, we work on storage. I work with people who work on storage. Oh, great. That's my conversation. That's kind of where the conversation stops.
Yeah. I wish I had like a better way to explain this.
No, I think but my takeaway from this was those are little, because the upside is that you have someone like me who doesn't understand it working with you on some of these things where I'm like, okay, if I understand it, then we're good. Like, if we can create something that where I, a complete novice in this field, would understand the impact better. That I'm here to actually, so it's kind of, I don't know if I'm like, what you remember whenever you had someone would have a technical presentation and the question was, well, does your mother understand it? I guess I'm the mother in this situation.
Yeah, we always said that at Media Lab, like when you got ready for like sponsor week, which is like demo week, it was like everybody had to have like their technical demo ready, and then you also had the like if your grandma walked in demo ready. But it was a really good exercise, right?
Yeah.
I think it's like you amplify like the message of your work if like the random person who walks in the room knows what you're doing and walks out and tells their friends. So
actually the better analogy would be a Congress member.
Yeah.
Right, because that's actually what needs to happen. Right, it's like when you do an NSF, when you get actually an NSF grant, the first thing that the program director asks you to do is write an abstract for the Congress member. So they can
but there's like California Congress members, there's like Florida Congress members, like you have such a wide range.
Well, no, but you're also, or not so much the Congress member as the staffer who needs to explain it to the Congress member.
Exactly.
So they're actually a little bit more. It's more even knowledge. The staffers are even knowledge based because they don't.
I hope. I was gonna say, I hope whoever watches this recording is gonna enjoy like this part of it.
Well, so far we haven't used any bad words. So.
I know. Oh, yeah, because my sound hasn't gone out or something else. So
we've got some congressmen who watch it and see what we think about
shut down.
Well, it's been so crazy. It's been so busy that I didn't even realize that last night that Dianne Feinstein died. So speaking of Congress people, so I was like, wow, I just discovered that. So
I just heard that.
We can edit this part out. This discussion I'll edit out.
Yeah, no, but we should do that actually quickly this time. I mean, I really want to get to that. So maybe we can, Stephanie, we can quickly put the recordings in some place, and I can look at them and we can cut out sort of the sessions that I have. Because I really want to quickly get them.
They're all on the I did it all on the cloud this time, so which I'm not sure why I never did that. So they're all, I can just give you the links to all of them, to everything right now.
Very cool.
But I was going to work with so that's, well, as a wrap up, we can say that I'm going to work starting beginning of next week with Yelena and between the two of us, going to start to clean up all of the recordings, get them up, see if there's anything that needs to get fixed. And we'll get them up as they get finished. We aren't going to do like one big release or something.
So I'm just going to wrap the sessions that, we can also distribute that a little bit, right? So, so that's not all you and Yelena is working on that. We can.
Well, Yelena doesn't have any event. We don't have any other event coming up right away, so it actually would be useful for her, and it'll give her some time to.
But we still don't have the ACM rap recordings.
Yeah, they are. Those are up.
They are.
Yeah.
Oh, they are.
Yeah.
I didn't realize that.
Yeah.
Cool.
Yeah. They did it for us. I mean, we cut them, but they did all the loading. It's on the ACM rep site. It's not on our site for ACM rep.
Yeah. That's cool. Yeah. So then I think I just would like to then look at as soon as you have them cut, so that I can look at the recording of.
Okay, I'll give you the links. I'll just send the links. Well, anyway, so yeah, I'll send the links out to you and to Yelena to and then she can start working on it, and you can at least look at what there is. And and the same with the slides. And we'll be doing also a quick survey. And I started writing up my list of follow-up things for all of the sessions that we need to do, or at least the sessions I was in. That's actually something I might add to the survey is like, hey, what follow-up things did you get out of your sessions that one of us might have missed that we need to also follow up on? So
I think it would be cool too. Maybe you said this because my internet's going in and out, but I loved I think it was Spot's idea about like if there's an email that goes out to everyone at the end of the conference, like mentioning like, hey, if you'd like to be involved in a working group to develop like an academic open source conference, click here. I don't know what the click here is.
All right, maybe part of the follow-up is like, hey, was there a follow-up discussion that needed to happen? Is there like, and that would be one that somebody would be like, yeah, we had a working group that, and maybe I'll do it I'll figure it out. I'm going to do a little bit more detailed follow-up, and because I feel like this group, a lot of people in this group actually would, unlike most surveys I send out, which are like, I get very little response back. This one, I feel like this group actually has a lot to say. So
I thought that actually this is a fantastic idea, right? And thank you for reminding me, Emily, because the example of a working group for for the open source conference, right? I mean, we can maybe put together a set of working groups that are coming out of this conference, right? And we can basically say, okay, let's have these working groups and provide communication channels with it, and then people can start, and we can basically ask people to subscribe to these working groups. And I think the open source science people have actually found a platform that's non-Slack platform that seems to be actually pretty good.
Yeah.
And I think to start, like his suggestion was really kind of to keep it as like one conversation. So there's like
but then you can offer
a conversation that's like everybody, but then it could sort of develop into, like you're saying, more like a conference committee or like working groups or something. But
because I think there is sort of this, but I think that's why I want to do this pretty quickly is to actually get through these recordings. So we have that energy, we have the memory, we have like follow up, because I think it would be really cool to say, hey, here remind yourself of a particular section, and we're thinking of like creating working groups if there's interest.
Yeah, when I really liked his idea too of even just like, I mean, there's still decision making involved, but like just like picking a time and saying like we're gonna have our next meeting here or whatever, put a doodle poll for the next meeting. I like the idea of like a meeting as a next step, just like getting something on the calendar, holding time, because I also relate to his like I'm on like so many Slack teams.
It's just
I'm sure we all are. It's like and they're all really useful, but like having another one just yet, like I don't know if people will track it.
I think that John Starr at also a fantastic job, but John Starr is even putting it to the next level of what he does in open source science. I'm really in awe how he's like sort of really energizing these interactions now
Yeah.
on these various work groups, and I think I kind of like to copy that. That's really cool. Yeah, I think that would be really cool if we can sort of create a very active community around the OSPO, right, with lots of ideas. And it's not just this once a year, 3-day thing, but it's actually a continuous process that actually feeds also into how we actually do the next event. And
Right.
yeah, I think that would be very cool. I agree. I think that also, I mean, I think that every year now, since we're doing these OSPO-based symposium, right? There's this even more energized community.
Yeah,
I found that this one was like even better, right? It was like last year was really good, but this one was definitely like really another step. Amazing. So really happy.
Well,
Thank you.
Oscar joined us, so I guess we did have somebody coming just for the just for the wrap up.
I need to run.
Hey guys.
Oscar, you can take
We
over.
just pretended we're like, yeah, screw the wrap up. We're just kind of like, we're gonna get that out. See, we did.
Yeah, I was on the call and it got longer, so I just had to skip the beginning. But I was wondering about, you know, what you just talked about, the sort of creating the community around open source also for kind of to check the checkboxes of the standard academic pipelines. I mean, my sense was that people are actively talking about this whole, like, what are the academic incentives and how that fits into the OSPO, right? And what we are doing as both like individual project leads and the organization.
Yeah.
And so, yeah, what did you think about the, you know, the open source conference as a journal or something with proceedings?
Yeah, there was a very, very lively discussion about that. And it was really anything from, you know, like a traditional conference to like a really crazy conference, right? But I think we sort of realized that we need to really sort of stake out more so the criteria to make it both acceptable, right? So one question was who's sponsoring this conference, right? Is it ACM? Is it IEEE? Is it, I think it was Oasis Open Oasis, or is it CNI, right? There's all these different organizations, and some of them have more like a engineering image that was not necessarily very conducive to like the kind of membership we want to attract, to like, you know, not very well known, so it's not maybe as respected as it should be, right? So that was like more into the Oasis Open or Open Oasis, I forgot, but I think that actually initiative or organization came up again in the security panel. And apparently among security professionals, it's a very well accepted academic institution, but mostly rooted in Europe, not here, right? And
wait,
so
what is this institution?
Oasis Open or Open.
Oh,
yeah.
Have you heard of it?
Oasis. Let's just
see. That's the thing that I haven't heard it either, right? But it's like among different other disciplines, it's actually very well known. And so maybe, given that, for instance, people like Jacob Green, you know, he was suggesting it as sort of as an agency that could sponsor, or like an organization that could sponsor an open source conference. You know, and I was like, I've never heard of it. So then everybody's like, well, then it's probably not good enough, right? And it's like, well it's just my community.
Well, I think the suggestion of CNI, which I had never heard of before, but I think, you know, now that I've been to one meeting, I'm like, it's a very inclusive of different areas, and that's what I liked about it. Like, it had a lot. It wasn't just like the different disciplines. It was very inclusive of different disciplines, and that was, I think, that's what you're trying to like find, is a discipline where a social scientist would fit in as well as an engineer. And so that's why I was like, when that came up, that actually seemed, and it's you know, recognized from an academic perspective as well. So
oh my God, one of their sponsors is Fractal Consulting.
Yeah.
What?
Who was
Their
that?
their
Run.
motto is
What?
think heavily, act ethically. I'm sorry.
I think we just lost. Anyways, you just lost Carlos. He had to go. So
Oh,
when
yeah.
the chair of the conference leaves the final thing, I guess it's over.
Okay.
But all right, cool. Well, thanks everybody. You're like the last, till the last moments. But yeah, if there's anything else anybody has that they want to wrap up with, we may not post this particular little segment. We'll just end it and whatever the discussion on Skyhook.
Fractal computing. Okay.
So,
Well,
but
it was
we'll keep this because it actually was useful to wrap up the part of it. So, all right. Well, we should probably all get going. Thanks everybody who on the call who helped out and did things and had sessions and showed
Yeah.
up and ate the
and
food.
thanks Tiffany. It was a great event.
Take care. Thanks.
All right. Bye everybody.
Bye.
Bye, everyone.